All right, sixth graders, this lesson is going to focus on finding the prime factorization. The other day we worked on defining prime and composite numbers. So let's review the vocabulary words we've already filled in. Factors, a really important word. Factors are numbers multiplied together to get a product. So for example, some factors of 12 would be 3 and 4, because when you multiply 3 and 4 together, you get 12. Prime number, we said, is a number that only has two factors, 1 and itself. So an example of that would be 2. The factors of 2 are 1 and 2. 2 is prime. Composite number, it has more than two factors. So an example of a composite number would be 12, right? 12 has more than two factors. That's going to be really helpful information in working with prime factorization. So with that said, let's fill in the definition for prime factorization. Prime factorization is where you're taking and writing a composite number as a product of prime numbers. And we write the prime factorization from smallest prime to largest. So really, we're going to be writing an expression that has prime numbers and multiplication signs. Let's look at this a little bit more. So go down to where it says factoring a number. Factoring a number is where you're going to take a number and you're going to pull out factors that when you multiply, give you that number. So I want you to think of the factors of 24 right now, and I'm going to write them over here just to list them out for you. You can do this with me, you do not have to. So the factors of 24. 1 and 24 are factors of 24, but I cannot use 1 if my goal is to find the prime factorization, because remember, 1 is neither prime nor composite. So that wouldn't work in trying to find the prime factorization of 24. Is there anything times 2 that gives me 24? Yeah, this is an even number. Thank you, divisibility rules. 2 and 12. Is 3 a factor of 24? 2 plus 4 is 6, and 6 is a multiple of 3, so we have divisibility. So that means 3 is a factor. 3 and 8, when multiplied together, give me 24. Anything times 4? Yeah, 4 and 6. Anything times 6? Or anything times 5? Nope, doesn't end in a 0 or a 5. Anything times 6? Repeat, I'm done. So now you can pick any of these factor groupings and break 24 up into that. Let's just go with 3 and 8. I could pick 2 and 12. I could pick 4 and 6. We cannot pick 1 and 24 because 1 is neither prime nor composite. So we're going to start by drawing some branches here, and we're going to say that the factors 3 and 8 I can break 24 up into. Now we're going to ask ourselves, is 3 prime? Yes, so we're going to show that by putting a circle around it. Is 8 prime? Nope, I can break 8 up into some factors. What two factors give me 8? You cannot use 1 and 8. 2 and 4. Yeah, is 2 prime? Yes, it has only two factors, 1 in itself. Is 4 prime? Nope, I can break 4 up into 2 times 2, and we know that they are prime. Now, this is not the prime factorization for 24. It's just we took 24 and we factored it. So now prime factorization is where you're writing a composite number as a product of prime numbers. So we're going to take these prime numbers and put multiplication signs in between them. But here's the tricky thing. You write the prime factorization from smallest prime to largest. I have a little reminder for us right here. So the smallest prime, only focusing on those circles, is 2. How many of them do I have? 2 times 2 times 2. Did I get them all? Yes, I have 3 of them. Times 3. Did I get all the prime factors? Yeah. Now watch, when we multiply this together, what's 2 times 2? 4. Times 2, that's 8. Times 3, 24. This is the prime factorization of 24. We can also write the PF in expanded form or exponent form. Is there a factor being used more than one time in this multiplication sentence? Yeah, we learned that we can use exponents to represent repeated multiplication. So 2 is being used as a factor 3 times. I can say that's the same as 2 to the 3rd power times 3. These are the prime factorization of 24. Cool, right? Let's do one more together. So we have, we're going to factor 525, and then we're going to figure out what's the prime factorization of 525. Don't be intimidated by the large number because we know our divisibility rules. So I want you to think of two numbers when multiplied together that give you 525. And you might go, Miss Cleaver, I don't know. Well, use your divisibility rules. It ends with a 5. So we know 5 is a factor, and then we could go 525 divided by 5. What would that be? If you're not sure, take out a calculator and go 525 and divide it by 5. You will get 105. See how our divisibility rules are helpful? Now, is 5 prime? Yeah, the only factors of 5 are 1 and 5. So we're going to circle it. Is 105 prime? No, it ends. This number's last digit is 5. So we know that 5 is a factor of this. 5 goes into this. We got to figure out how many times. So 5 times 21, right? And if you're like, Miss Cleaver, how'd you get 21? You can go 105 divided by 5 and you'll get 21. We know 5 is prime. Is 21 prime? Well, it's not even, so I know 2 doesn't go into it. But 2 plus 1 is 3, and 3 is a multiple of 3. That means we have divisibility. That means 3 is a factor of 21. 3 and 7. 3 is prime, and 7 is prime. All we did was factor 525. Now our job is to figure out what's the prime factorization of 525. We have all those prime factors. We just have to write them as a product of prime numbers. So with that said, remember, we want to find the smallest prime and then write to the largest prime. So the smallest prime here is 3. We're going to start with that. Product of primes is the prime factorization. So we've got it. It's a multiplication sentence. 3 times 5 would come next. Times 5 times, what's the last? 7. Can I write this prime factorization in exponent form? You bet I can. 5 is being used as a factor more than one time. So I can write this as 3 times 5 to the second power times 7. Make sure your note sheet looks just like my note sheet. And if you have any questions, maybe jot them on the back so you remember, like, gosh, Miss Cleaver, you know, how did you start this one? Or how did you get this? You can make sure to ask me tomorrow.